Ma'am, shall we start?
Yes, ma'am.
Okay.
Good afternoon, everyone present here. It gives me immense pleasure to welcome you all for the final day of Faculty Development Program on exploring new horizons in mathematical research. First, I would like to invite our head of the Department of Dr. C. Manoharan to deliver the welcome address. Sir, please.
Yes, okay. Good afternoon. I extend a warm welcome to all those attend in the last day event of FDP on exploring new horizons in mathematical research, organized by the Department of Mathematics, V.O.CHIDAMBARAM College, Thuthukudi. Special welcome to the participants who join from various states. On behalf of our department, I would like to express our gratitude to our guest, Professor Dr.C. Vijayalakhsmi, Department of Statistics and Applied Mathematics, Central University of Tamil Nadu, Thiruvarur, for accepting our request. Thanks, one and all, and enjoy the lecture on recent trends of machine learning techniques and applications. Thank you. Thank you very much.
Thank you, sir, for your warm welcome. Now it's my honor to introduce our esteemed resource person for the day. To do the honors, now I invite Dr. J. Martina Jensi, Assistant Professor of Mathematics, to introduce our resource person.
Ma'am, very good afternoon, one and all present here. I am very pleased and honored to introduce an eminent resource person, Dr. C. Vijayalakhsmi, Professor, Department of Statistics and Applied Mathematics, Central University of Tamil Nadu, Thiruvarur. Reading her short profile itself spans to many pages. However, I'll try to introduce her with a striking yet a short note. So, ma'am has more than 2 decades of teaching experience apart from her industrial experience. Dr. C. Vijayalakshmi has served as teaching faculty in various prominent institutions like Satyabama, Vellore Institute of Technology, and now she is serving at Central University. She has been a constant receiver of many patents, including one for chatbot app. Madam has successfully completed 2 projects and has convened training programs under Rajiv Gandhi National Institute of Youth Development sponsorship. Her research expertise is stunning. She has 130 papers published in international journals and 31 national paper presentations to her credit. Her research areas include optimizing algorithms, stochastic and statistical methods, and data analytics, machine learning, and deep learning. Under her guidance, nearly 19 scholars have been awarded with PhD degree. She has also authored 4 books to her credit. Her accomplishments are vast, and to be specific, she has visited countries like Kuwait, Singapore, and Malaysia, and has shared her words of wisdom in the international forums. Apart from being a reaching faculty, she has served as coordinator for various events in other institutions as well. She is a life member of Indian Society for Probability and Statistics and advisory committee member for VIT Bhopal. She has shared her expertise in more than 100 invited talks. It's an honor and privilege to share the forum with such an illustrious and intellectual prodigy. Thank you for sharing your valuable time and knowledge with us, ma'am. We are very much blessed to have you amidst today. Welcome you, ma'am.
Thank you, ma'am.
Kindly take over the session, ma'am. Thank you.
Thank you, ma'am.
Thank you.
Arise, awake, and stop not till the goal is reached by Swami Vivekananda. Ma'am, am I audible?
Yes, ma'am.
Respected Professor Deva Manoharan sir, head of the department, and Dr. Martina ma'am, Densi ma'am, and all the dignified professors from various institutions, research scholars, Good evening to one and all present here. At the outset, I would like to thank Almighty and the organizers of this FDP, along with the head of the department, for giving me an opportunity to share some of my ideas related to recent trends of machine learning techniques and its applications. So, this machine learning, what does it do? In what way it is linked with mathematics and statistics? Frankly speaking, at the background of this machine learning and deep learning techniques, we use probability concepts, statistical techniques, linear algebra, calculus, etc. So this has got a wide applications in various fields wherein we try to move step by step and train the machine to understand what is happening. So unlocking the power of data. What is this unlock? How can you unlock the data? Is it possible? It's like a sky. So where do we apply this machine learning techniques? We apply the machine learning techniques in different fields like natural language processing, search engines, medical diagnosis, detecting credit card fraud. Nowadays, it happens a lot. We could see in papers and other social media where the fraud detection is very slow, and many people in the society lose their money and fail. Stock market analysis, even the younger generation just do wonders in stock market for the earning. Bioinformatics, DNA, RNA sequences, and the healthcare and surgeons, they also use this. Speech, handwriting recognition, object recognition in computer vision, and playing games. We play different types of games and we try to check whether as a single person without any opponent, am I in a position to do that? Nowadays, artificial intelligence has entered where you have this robotics also. So by using this robotics, even the classroom teacher has been replaced in some of the countries. So if that is the case, what are the mathematical and statistical approaches we can use over here? To start with the mathematical approaches, we use the calculus of single variable, many variables, that is several variables, and linear algebra concepts, algebra, and we move on to statistical approaches like statistical learning, naive-bayes, instance-based learning, and neural networks. And now neural networks plays a vital role in making us to understand how am I going to train this machine in such a way that it acts like a human being. That's the main thing over here. So the broad overview, I would like to place it over here the methods which are being used over here as a regression, which is a prediction. Like COVID-19, we had different types of vaccination like Covaxin and Covishield, where people wanted to analyze the risk factors and what happens after having the vaccination. Are we tested positive or not? All these things have been taken into account as a mathematical modeling. Non-linear methods. The curve may be linear or non-linear, or for which unstructured surface are we in a position to understand about the nature or analyze the properties. Then unsupervised learning, sequential and reactive settings. Complicated problems are being solved by different researchers in different fields. So our fundamental types of learning, I would like to touch on it. Supervised learning, where we try to classify and regression. Reinforcement learning goes for agents. Different types of agents are being just substituted over there to act on it, to learn or have a knowledge extraction. Unsupervised learning goes with association of different types of attributes, characteristics, etc. Clustering and density estimation. The other things which we could place it nowadays in many of the practical applications, we don't use this as semi-supervised learning and active learning. Friends, to touch this particular part of the supervised learning, we just think about what will happen tomorrow. How are we going to predict it? So based on the existing history or information which has been extracted, we try to use that and interpolate or extrapolate, and we are trying to get the prediction. And knowledge extraction is very, very important. We are trying to frame different types of rules. And framing the rules as human, we'll be in a position to understand what is that. but how to train this machine to understand how the rules are being framed. And by using some different types of operators, we try to have a single loop structure or nested loop structure also. Then compression. Compression is the data. By just seeing the data, we'll be able to analyze or not. No, we try to analyze it by using some techniques. And outlier detection. Outlier is always like we try to say that it has to be inside that, and the distance between all the set of points with respect to a particular point which is too far, like we try to note it as an outlier. So unsupervised. Unsupervised. I just wanted to place a small example for the previous supervised. When there is a teacher inside the class, we try to say that teacher is looking at us. So the students are forced to listen to the teacher, the instructions, rules, regulations, etc. Unsupervised. What normally happens when nobody is there, like we are not able to predict what they will do, so kind of no output. And we try to see like this type of class students behave like this, so we group the similar instances. What is the recent trend applications over here is like customer segmentation in CRM, image compression. We try to take a photo and give it to somebody to enlarge it or magnify something like that. The photographer says that this particular photo has got so much of disturbances, blur is there, it is not clear. So what type of mathematical and statistical techniques can be accommodated to have this image to remove all the noises? Then bioinformatics. Moving on to the reinforcement learning. This is a kind of sequence of outputs we try to give it. So we don't have any supervised output over here. So there are chances the output of the time, how much it takes, maybe it may be delayed. And credit assignment problem, we just play games, video games, robot, and multiple agents. Why this multiple agents is like we are not able to extract the information from a particular agent. We try to adapt different types of agents to have the proper output. Moving on to the next, machine learning of linear methods for regression. We use coefficient of subset selection, shrinkage, methods for classification. LBFR is a beautiful technique. It's based on the linear algebra of linear basis function regression. And piecewise linear, splines, and wavelets. Wavelet transformation techniques are being used over here, like local smoothing and kernel. Kernel plays a vital role in your prediction and regularization and one-dimensional smoothing splines. When we just touch the non-linear regression, we just move on for artificial neural network, kernel trick, maximum margin classifier. Whether the entire data which has been taken into account for classification, is it lying inside the margin or not? Then support vector machines or in turn sparse kernel methods. How to assess the model? What has been designed by us in machine learning is like we try to find out the training and testing, and the beautiful term is residual analysis, that is error. Error has to be minimized. So different types of techniques like Law's rank principle of model selection and theoretical model selection are being implemented. How to attack the large problems or the complicated problems in the globe? We use PGM, probabilistic graphical models. Any type of problem can be just converted into a matrix form, or it can be converted into a tree diagram or a graph like that, in which we have tree models, non-parametric learning models, variational inference, sampling methods, and we combine some of the techniques over here and try to see whether we are able to get the output. And finally, boosting. When we just move on to unsupervised learning, we have K-means clustering. And when we talk about this K-means clustering, we could see like what is the value of K to be predicted over here. In what way this is going to help us. And this particular thing makes us to understand the different types of, Professor Jackson, sir, you have raised your hand. Any doubts? Professor S. Jackson?
Ma'am, I guess by mistake.
By mistake. That's okay, ma'am. Is the flow okay, ma'am?
Yes, ma'am, it's okay, ma'am.
Yeah, that's fine. That's
Okay.
Okay. So when we talk about this unsupervised, we have this K-means clustering and mixture models and expectation maximization algorithm. So the main idea, sometimes when we touch this optimization techniques, we try to find out the extremal values. And in this extremal values, we just have some objective function, set of constraints, then non-negative restrictions. And what we try to do over here is the values of the unknown things, how we are trying to find out by using different types of constraints, and we are trying to get the objective function. Non-IID, that means sequential and reactive settings. So when we have in healthcare data, when we just see like the data will be two sequential, and sometimes there may be some data which is missing also. So if that is the case, what shall we do? Are we able to analyze this missing data? Because there should not be any misclassification also. And next one is sequential decision theory. What is this decision? Decision is a kind of inference. We take up a problem. For example, I manufacture 3 different types of products. With the available resources, I try to have some indifferent constraints. My objective is to maximize the profit like that. So what type of decision I take after finding the entire problem unknown values if I'm able to get it. So we convert all the set of constraints as in terms of a matrix as Ax less than or equal to B, Ax greater than or equal to B, or Ax equal to B. A is the coefficient matrix and X is the unknown, and B right hand side is my available resources. With this available resources, I should be in a position to manufacture or produce some of the items in the real-time scenario. Next, learning agents. These agents cannot learn by itself. We have to frame some rules, regulations, and try to see. For example, I could say like framing the rules. If somebody is asking me like, does it rain today? Or it's going to rain like that. So I have 2 choices of answering in Boolean type. Yes, it will rain, or no, it will not. So if that is the case, under that, this is the first layer of asking 2 questions, yes and no. Under yes, I may have some other rule like saying that capturing the attribute or the characteristic of that problem, asking if it is raining, yes, then should I take my umbrella? Then I can have a nested loop of framing a rule. If I'm going to take an umbrella, am I going to take it from my house or going to purchase or going to take it from my institution? So like that, we try to train these agents by learning, in which 2 different types of one is training at the data and testing the data. Next one, we have reinforcement learning. When we talk about this reinforcement learning, this one makes us to understand along with the parameters which is involved over there, how it works. The learning games. So when we play these different types of video games, for example, we have it in our hand and we try to play the video game. We try to say that we want to shoot somebody or just shoot the shots over there, like we try to move it as from straight, right, left, right, like that, where a kind of transformation is happening in the 2-dimensional or 3-dimensional geometry, having it starting from the values of the coordinate x0, y0 to x1, y1, x2, y2, like that. So now we move on to the main part of how this mathematics and statistics help us to, in machine learning, to analyze a real-time scenario problem. So when we talk about this real-time scenario problem, we just think in different ways, like whether we are able to design any mathematical model over here and solve with the existing algorithms or statistical techniques or optimization techniques, where we try to test it and train it and just say that our proposed algorithm is considered to be one of the optimal or what can be considered to be an appropriate over here. So if that is the case, how we are going to do that is one part. And the second part is, after designing the algorithm, the flow goes like this. The problem is initially given. Then we try to convert it into a mathematical model or optimization model or a statistical model. After converting, we analyze the different types of variables, decision variables, controlled variables, uncontrolled variables, all these things we analyze it. And we design some algorithm. Then we try to write some code in different languages, either MATLAB or Python or like that, or any open source software tools we try to apply, and we just try to test it with the real-time data. The model works out with the real-time data, then we just come to a conclusion, yes. And there lies two different options over here. Many professors, they try to ask, what is the complexity of the algorithm which you are using it? How long this algorithm is running? Does the time taken by this algorithm is just 2 seconds or 3 seconds rather than solving it manually? All these questions comes out. We try to take it in terms of convergence. So how it is and what has to be done. So what is the basic thing which we can just, when we have the real-time scenario problem? The real-time scenario problem states that implementation of some mathematical or statistical model to analyze the impact of purchase and sales of foreign institutional investments, that is FIIs, on Indian stock under various sectors. That means nowadays we could see, like, from starting from the younger generation till the older generation, they try to learn about the stock market under various sectors. We have different types of sectors over here: industrial sector, and inside we have manufacturing, production sector, assembling sector, testing sector. Then we go for quality control, all these different types of things. But here we want to analyze this FIs on Indian stock. So what are the things? First, given this problem FII, we are trying to analyze what is our objective and what in the literature review many researchers or authors or great scientists or mathematicians have done it, and what type of hypothesis we have to set, and what type of methodology, and how we can analyze this data, what is the future scope, and the model which has been designed should be useful to the society also. So what is this problem when we talk about FII? FII is, once again, I'm just moving over here. It is foreign institutional investments. Foreign institutional investments. And this investment, how the impact is on the Indian market. So this financial markets, what we talk about is like how this foreign investors, they try to invest in the financial markets of our country, and what is the impact, what is the risk factor, are we able to predict anything? All these things can be just played over here. So to start with this FII, foreign institutions, this investigation always plays a vital role, that is a crucial role in under two different things. One is about the capital flow, that's very important on that particular thing. Second one is influencing stock prices, because it's going to be uncertain, we do not know. Suppose if we want to just mobilize fund and just deposit or just put it in some fund, in that we just always analyze the nature of the company and the trends of the company and the consistency of the company. Is it the best policy to deposit that money in that particular company or some stock? So this particular study research investigates how much of impact on this foreign institutional invest purchases as well as sales. Whenever we talk about the purchases, we have to think about sales also. So sales across the various sectors. It's not only one. So two different types of objectives we always have it, when it's going to be a single objective or it's going to be a multiple objective. So here in this particular study, we just think about how this impact is with respect to purchases and sales of various sectors in the Indian stock market. They may be resident of abroad and they may be staying anywhere across the globe, and how do they deposit, in what way, all these things can be analyzed. So we are in a position to take the data from 2014 to 2023. So data has been retrieved from the real-time market, and it is a real-time data, and we want to analyze it by using machine learning techniques. So what is the main objective over here is, like, we try to say that the impact is a beautiful word which is being often used in mathematics, statistics, and optimization, or any engineering discipline, where we want to analyze how much this influences. Because of this, what are the problems faced? Do I having any loss in that? All these things can be analyzed. So we try to analyze and study the impact of purchases and sales of FII, foreign institutional investments, on the Indian stock market. That is going to be very, very important point which has to be noted. That is Indian stock market under various sectors. So when we talk about the existing studies, what they have done in the literature, they always talk about the overall market. They try to say, I think whenever we listen to some news in YouTube about this financial market status or conditions of any company, they always say that do not invest, invest. And yesterday it went on very well today. So some kind of fluctuations and uncertainty is always there. So it has got some limited analysis on some of the sectors only. They may take iron and steel manufacturing sector. They may take some healthcare sector like that. But with this research, wanted to fill that gap. What is the gap over here? The purchases and sales on individual sector indices. Ma'am, is that fine?
Yes, ma'am, it's fine, ma'am.
Okay, ma'am.
Yes, ma'am.
So we would like to set some hypothesis. As we are all aware that the hypothesis which is going to be set over here is null hypothesis and alternate hypothesis. And null hypothesis is defined as H0 and alternate is defined as H1. So how do we set this with respect to the population? Is like we try to say that there is no relationship between buying and selling activities. That means I want to purchase something from Amazon of US. So I try to fix it as there is no statistically significant relationship between buying and selling activities of FII, because the movement of the sector, that means what happens to the product movement in Amazon, like in that particular Indian stock market, how it goes. And the alternatives, just contra to the null hypothesis, or we can say complementary, then it is a statistically, there is some relationship. That means just buying and selling of activities of FII, then we can say like on the Indian stock market, you have some problems which can be analyzed. So relationship is there. And this is very, very important point is how the sector with specific indices, that movement has to be analyzed. So how we got the data, in what sense, and how the methodology has to be adapted. The first thing we would like to say that the data was collected from NSE. We say NSE is National Stock Exchange, and which is available in online as a public domain database. And the next one is, we call it as a SEBI. The role which is played by SEBI is a great thing throughout this, and that is Securities and Exchange Board of India, SEBI. The period which has been taken is like from 2014 to 2023. So in this particular case, like the observations, the sample size, we just took it as 2438 observations, which is a little bit huge sample size. And this analysis, what does this analysis includes? Because whatever the things which are being analyzed over here as a model, this should be helpful for the people where they invest, purchase and do sales. So this has got some descriptive statistics. And when we talk about the descriptive statistics, we always try to analyze the data with different measures. What are the statistical measures we would like to take? It is like measures of central tendency, mean, median, mode, minimum, maximum. At which particular point this particular stock has gone to that extreme level and which point it has come down, so that it is an indicator for us not to purchase that. And next one is measures of dispersion. Then we can move on to kurtosis and skewness also. And the relationship between the different types of variables over here, that also plays a vital role. Then the regression model. When we talk about the regression model, it can be either single variable regression model or it can be multivariate regression model. And all these things will help us to analyze this data. Next one, the advanced techniques support vector machines is mainly based on the mathematical modeling of linear algebra and decision tree and random forest. What is the need of this is like, after purchasing and doing the sales, we want to analyze how much this is influencing, which are the predominant factors which is trying to affect that, and what are the uncontrolled parameters leads to some risk factors. So all these things can be analyzed. So data analysis, when we start with that, the first thing is it involves cleaning / pre-processing the data. The need of this is like, after getting the data from Kaggle or from NSE or from SEBI, from the public domain database, we could see like there are chances some data may be missing over there. Like, so it is very difficult for us to analyze that entire slot of 2438 observations. So this help us to apply some pre-processing techniques and find out the relationship, and that too for with specific indices. So what type of statistical analysis we can do to over here, and in what way it's going to help us? To start with, our overview of the data that is taken for the study. So when we have this overview of the data to be 2,400 plus data set, like it involves the different types of measures, like we may have it like the name of the sector, the value of that, and cumulative value, and we may have it on that particular day. Is it increasing or decreasing mode? All these things. So why we should do this descriptive statistics is like to analyze how much of deviation it is with respect to a single thing, the single deviation with respect to the entire lot average. So this gives beautiful insight on the data set. So when you just look at this descriptive statistics from January 2014 to December 2023, the latest data which has been taken over here. Okay, now what does this particular data contains as variables? The variables are listed as the gross purchase, FII, foreign institutional investor gross purchase. The next one, immediately it comes over to gross sales. Next, I think you're all very much familiar with this Nifty. Nifty, whenever you open YouTube, you could see like many people just talk about this Nifty, like it's like a trading. So this trading has got some sub variables also. What is the sub variables? That Nifty is connected to energy, automobile industry, information technology, healthcare, pharma, oil, gas, then infrastructure, then FMCG, that is like we try to say about the financial, then banks. So all these things are taken to be the variables. So the data has been analyzed over here for more than 10 years plus. In that case, the mean, standard deviation, median, what is the minimum value, maximum value, range, and skewness, kurtosis, and error. All these things we are able to get it through Python. And the only thing what we can do it over here is we have to have some interpretation of this descriptive statistics. That's more important, because having the output by using some MATLAB or Python is not a thing like we have to go for the inference. What are you trying to say that? When we talk about the skewness, it is in the range of a normal distribution having minus infinity to plus infinity, and we try to analyze whether my value was left skewed or right skewed. There is a problem. It's going to be lying on the positive side or the negative side. All these things can be analyzed. So what type of inference when we have it based on this particular table is like, we try to just predict that the average and the median of purchases and sales, they are not same. That means it is not normally distributed. Whenever we talk about the normal distribution, friends, we are all aware that this distribution is a bell-shaped curve, and the range is from minus infinity to plus infinity. Probability of having it this minus infinity is 0, and 0 to infinity is 50%, half. And we try to say that there may be a peak on that, and which has been the skewness, and kurtosis is based on whether it is a lepto, meso, or plateau curve, like that. Then when we analyze the skewness and kurtosis based on this analysis in the previous case, we could see like the data points are concentrated towards one side. That means, excuse me, we try to say that it is lying on the left side or right side. For example, when we analyze the class students' data and if they are lying on the left side towards minus infinity, we try to say that some predictive and corrective measures have to be taken to the students by giving challenging experiment, making them to do assignment, repeated test, etc. like that. So in the similar way, we give some insight, and mainly the stock is got different types of fluctuations. Minute by minute, second by second, this NSE indices may change. So if that is the case, the volatility and the fluctuations of this FII activities and NSE indices will be analyzed based on this descriptive statistics. Then correlation matrix. For the entire matrix, for the entire data, such a big matrix, we are trying to analyze the relationship between the variables. How do we analyze it? It's not going to be a bivariate. Bivariate, when we talk about, we take any two things of XY variable, we analyze what is the relationship over there like. But now here, it is going to be with respect to the different parametric variables which has been taken, such as purchase, sale, Nifty 50, energy, automobile, IT, healthcare, pharma, oil, gas, etc. Along with that, after finding the relationship of each and everything with respect to another variable, we just plot a heat map the correlation. When we talk about the correlation matrix, we always, friends, we try to classify it as positive correlation, negative correlation, and null correlation. Positive correlation, always we try to explain the relationship between any two variables. For example, X is one variable, Y is another variable, year and population. When X increases, Y also increases. When X decreases, Y also decreases. They try to travel in the same direction. But on the other way of negative correlation matrix, we try to say that when X increases, one variable increases, one variable decreases, or vice versa. When X decreases, Y increases. Then finally, we talk about null correlation, no correlation. That means all the data points are scattered. I'm not able to have any type of whether a linear or a non-linear curve. So this purchase and sales, this particular heat map is a beautiful geometrical visualization where it helps us to find the relationship with respect to purchase and sales across the different types of NSE indices. So what do we analyze from this particular part of this is like, we try to say that it is positive, but very weak correlation, maybe 0.4, 0.3 like that. The values are too low between the purchases and sales along with, that is versus indices. So what we have to do in this, what type of inference we want to give it over here is like the other factors besides FII activities, they give more influence on the movement of NSE indices. That means whatever the factors which we have taken, apart from that, there are some extra outside environmental factors that has also been taken. The next one is the potential relationship between different types of variables, which is mentioned over here, that also can be expressed in a nice way based on this -1 to +1. We move on to the next part of this, support vector machine. The support vector machine is a kind of supervised machine learning algorithm where we try to classify the data based on this NIC indices and regression. Regression as such, I was just telling it, the glimpses of regression will be like either it can be a simple linear or it can be multi. Having so many variables over here, along with the error, we try to minimize and predict it nicely. So if that is the case, if some 1 crore points are given to me, I cannot just plot it in a 2-dimensional or 3-dimensional geometry. And it is important point to be noted that the entire set of data points had to be placed in a hyperplane. So what is this hyperplane? In a 2-dimensional geometry, we try to have two different parallel lines and try to classify or cluster it. What are the points which are lying above and what are the points which are lying below, in such a way that we are able to identify the optimal boundary. That's very important in the data set. So what does this hyperplane does? Because it's going to be a nth dimensional geometry, if that is the case, this separates the different classes What is the meaning of this classes? We try to say that if you consider some set of students, like we try to just classify them based on their demography. People coming from Tamil Nadu, people coming from Andhra, Telangana, like that. And the thing is, like, with highest margin, it has to be separated. And another thing is, it gives an effective classification even if the number of data or sparse matrix of 256 cross 256 also. So when we just use the algorithm, the background of this algorithm plays with calculus, multivariable calculus and linear algebra, and this helped me to analyze the different types. One is to regress. Regress means it's always, this regression help us to predict what is happening. So what type of regression I'm using as an algorithm over here, and what type of kernel. Kernel is a very, very important concept, and what is the cost and the parametric value of this gamma and epsilon value, because epsilon is going to be a smallest value. We are just trying to check it, like whether we are in a position to minimize the error over there. So how many vectors are being thrown out over here is being displayed over here as a last column. So in this particular thing, we analyzed by using support vector machine for FII purchase alone. The next part is like the support vector machine, which we have used it for sales. So what is happening over here? When we just look at into these two tables, table 3 and table 4, like we could see like the number of support vectors, the minimum number of support vectors over here in sales is 1941. And here it's also 1941, which corresponds to Nifty IT. So this IT here, it is going to be the same thing, information technology. That means we just try to say that this IT plays a vital role or a crucial role in the economic growth of our country. So what is the inference we would like to place it over here is like this support vector machine prediction model, it fits very well. Two things are there over here. Fitting. In optimization, in mathematical model formulation of any optimization problem, we always try to analyze whether this data overfit or underfit. The reason is like, suppose, for example, at layman point of view, when I just want to purchase a t-shirt for a boy of 18 to 20 years. So this age person may have different sizes. So by mistake, if I would have got some double XL or something like that, or triple XL or 4XL like that, we try to see that it doesn't fit into that. So the efficiency of the particular algorithm, and that is mainly dependent on your overfitting and underfitting. So this model helps us to capture the complex relationship. Normal relationship will be always like whether it is positive or negative or null, like that. Complex relationship, because we are trying to extract different types of futures, and there is two things, like one is future variable, another one is going to be the target variable, where we try to get the output. That meaning of this is like, for example, year and population, it is given 1950 up to 2025, it is given. Somebody is asking what was the population in the year 1934. So, or what will be the population in the year 2025, 2028, like that. If it is having, I cannot take the average of that of the previous record like that. So trying to have this, I can interpolate or extrapolate or try to analyze based on the present existing data and analyze and fit a mathematical model by using least squares method in such a way that it becomes either a linear model or a non-linear model. A linear model, for understanding, we can say it's a straight line y equal to mx plus c, slope and intercept, where after fitting the data, I may have it as y equal to 2x plus 3. Now, when somebody is asking me what was the population in the year 1925, I substitute x is equal to 1925. So 2 into 1925 plus 3, then I'm able to predict the value of the targeted variable y, which is going to be some value. So this inference, not only a very simple relationship, the complex relationships between different factors, like with respect to different sectors, that can also be analyzed. For example, energy sector with IT, in what way it is? healthcare with oil and gas, infrastructure with energy, like that it can be analyzed. So when we talk about this linear regression, and this linear regression is like, it is not only the relationship alone, it is to find out how much strong it is, strength of that particular model and characteristics. We always say that attributes, and this attribute, and we try to analyze it with so many independent variables with one dependent variable, or one dependent and one independent as a simple linear, and multiple relationship will be in a different way. So we try to fit it with respect to beta naught, beta 1x, etc., etc., etc. You can have n number of values where this beta naught, beta 1 are all the coefficients. So we try to have it as a linear model is going to be a straight line, and non-linear can be y equal to x power n is also possible. So this error term always help us to understand and minimize it in such a way that our model can give an accurate value. But the accurate cannot be considered to be the best value, it can be considered to be an optimal value. So when we just try to have the regressions, predictions of this NSE indices with respect to purchase, with all the things of this dependent variable, so many dependent variables over here as a multiple, and we try to estimate the intercept, FII purchase, the standard error with respect to intercept and purchase, then the t-value to analyze in the testing of hypothesis, and the p-value with respect to purchase and intercept. I think normally we will just, friends, you will all agree with me, trying to say that the calculated value which is done by us and the tabulated value, you try to compare it. Here also, we try to predict it with respect to indices and purchase. Similarly, we go in for error. Error is very, very important. How much the residual error has been minimized with respect to different types of, say for example, MSE, root mean squared value, MAE, adjusted R square, multiple R square. We try to check with different techniques of this along with testing with the statistic value. Similarly, previously we have done it for purchase. Now we are doing it for sales with respect to the set of dependent variables across the different measures like estimate, standard error, t-value, p-value, residual standard error, multiple R squares, adjusted R squares, F statistic, along with the different types of errors of MSE, RMSE, MAE. So what do we understand by analyzing is this, like we try to say that the purchase and sales has got a significant impact on Nifty 50 index. That means when you just go back over here, Nifty 50, that first row, and all other sectors. So this is playing a crucial role than the other things. And the p-values which we have used in Python, and this is associated with the coefficients. And why? What is the need of this is like to analyze, is there any significant relationship with respect to the indices? Whether we purchase or sales, whatever it may be like, it should have some relationship, and the relationship should be statistically significant with all the various or different types of sectors. And finally, we move on to logistic regression. And logistic regression, we call it as a generalized linear model. That means any model in mathematical model which we formulated, we normally ask a question, will this model be set to any type of data, numerical data? Whether we frame anything in numerical analysis also and frame it as a model, then we ask like, will it work out for any other data in the real-time scenario? So this helps us to analyze the relationship between a binary dependent variable or one or more independent. So when we talk about this binary, friends, we try to analyze it in terms of Boolean and check it out like based on the rules. If it is the relationship is not linear, then we have to enter only into logistic. That's way this logistic regression help us to analyze what are the changes in the predictor variables. That means I have so many variables with me. If any one variable is affected, does it influence other variables also? So do you have any changes in the predictor variables such that my outcome in the likelihood ratio, does it affect or not? So when we talk about this logistic regression, we have taken all the dependent variables and found this is another technique like the previous SVM support vector machine technique, but this gives more accurate value and inference than the other techniques. So the estimates, standard errors, t-value, p-value based on the intercept and FII purchase, along with the deviation. That is very important. How much of variance we have it, variations we have it, and we just find out the criterions, different types of criterions also. If it is too negative, in what way, and what are the risk factors which can be analyzed over here, along with the residual analysis. Same way, we try to analyze the implemented the logistic regression algorithm for different types of dependent variables with the different types of parametric estimates like standard error, t-value, p-value across intercept and sales. Previously, it is done for analyzed for purchases. Now it is for sales, along with all the criterions over here with errors. So what are we trying to analyze based on this analysis is like, we try to say that it is highly correlated with which one, that is the following things. What are the variables? Nifty 50, auto, automobile industry, energy, healthcare, and other things. That means if the FII, foreign institutional invest purchase value, increases, then the other set of all these variables also increases. So that helps us to say that whether we can deposit or do some actions on that, and purchase and sales help us to earn money a lot. Next, one of the another machine learning technique which has been used over here, implemented, is decision tree. And this is decision tree is basically from the graph theory concept, which has been I think many in literature, many in scientists, mathematicians are using different types of graph theory models. So here in this, we are using a probabilistic model also. So what is this decision tree? How does it help us? Like, we try to find out the relationship by the different types of methodology, but this is like what is the type of association you have it with different types of variables. That means first thing is we have to choose the most predictive future. That vector has to be extracted to be the root node. So when we talk a tree is always defined. Even the children says like, we have a root, then we go to the next layer with stems, leaves, veins, etc. like that. So this starts with the root and it goes with each layer. Layer is, I say, first stage, second stage, and mathematically speaking, we call it as a subset through different types of procedures, and decision rules are framed over here in order to get the perfect outcome on our sales and purchases. And the next point, important point to be is over here, we want to track what are the risk factors over here. Somebody will say that do not deposit, and that particular person may deposit all these things because he may be familiar with the stock indices. So when we talk about this Nifty FII purchase, like, we frame rules like this. If this FII purchase is less than a particular value of 5% or 0.053, then the rule goes with yes and no. Under yes, once again, a subset decision rules are framed, and we check it for the still more least value of this and say like how much of percentage it works out. One is 25%, one is 38%. Here also, similarly for the other ground, it says like 10% and 27%. This is Nifty 50 versus FII purchase. So this particular tree helps us to understand that it is split into two branches, we could see like, and this is less than of this, what is happening, whether we are able to find out increase in that or a decrease in that. But it gives an indication or a second opinion to the people that this purchase is greater than or equal to, then 50 is decreasing, getting decreased. And once again, this main tree, root, main tree is split into some more branches, and we try to analyze that. Then once again, it is split into two more branches, and wait to see that this Nifty 50 is more likely to decrease. So this has significantly, it has got some impact on this Nifty 50, and which is the key factor over here? The key factor is a purchase, that is FII purchase. Next, we move on to automobile, Nifty automobile versus Nifty purchase. And similarly, Nifty energy versus FII purchase. What is happening? Similarly, information technology, IT sectors, Nifty IT sectors versus the purchase, FII purchase, and healthcare. Now, this healthcare plays a vital role. Friends, you're all aware that the surgery, cardiac surgery or bone surgery or transplantation, everything is being done by robotics. So, how this mathematical model and statistical model helps the people to design the models in such a way that machine help us to understand which particular part has to be removed in the human body. So this healthcare and purchase. And next one is Nifty pharma versus purchase. What is the type of association we have it? And similarly, Nifty oil and gas, petrol, industrials versus association of FII purchase. Next, we move on to the infrastructure or the location of the building or the production or the manufacturing industry associated with FII purchase. Similarly, FMCG with respect to purchase. And finally, we touch all the bank sectors with respect to purchase. And this has got with different relationship, whether it is significant or not, that has to be taken care with respect to what? NSE indices, because NSE is the national wide which we get the indices throughout the globe. Then all these things are done with respect to purchase. The same algorithm is dealt with respect to sales. And what is the inference over here is like, we are trying to say that if the FII sales is too low over here, then Nifty 50, how it is affected. Whether it is moderate or do you have a slight increase in that? Because so much of fluctuations will be there. For a second, it will just increase, then it will just come down, then go forward. We have to be very alert in that. So do you have any moderate significance or high significance? And does this decision tree indicates a beautiful relationship between the sales and index values? And we just move on to the FII sales of the other things with respect to automobile, energy, IT sector, healthcare, pharma, oil and gas, infrastructure, FMCG, along with all the bank sectors of this. And finally, we go in for the technique of random forest. Forest, we all know it is dense. And you can have a very big trees surrounded with different types of nature. So this random forest algorithm, RF, is a versatile algorithm. What is the idea? Why we are using this algorithm is there any intrinsic features which can be extracted from the model? And we try to identify, is there any alterations in the data? When we just do a decision tree, which is dealt in the previous thing, like we want to identify which factor directly hit us like that. So in a high dimensional spaces, this decision tree doesn't help us because we have a problem of overfitting. To have the model accuracy and robustness, to have a stability in our problem, stability of the algorithm and reliability and consistency prediction of the algorithm, this random forest help us with respect to complex dynamics. So when we use this random forest of NIC indices and purchase, we could be able to analyze how many trees can be generated with respect to each and every variable, how many splits are there, what is the residual error analysis, variance. Variance always help us to analyze the deviation with respect to the current variable. And this is going to be indices with purchase. And this table depicts the NIC indices with FII sales. So what is the interpretation over here is, excuse me, we are able to design 500 trees. Manually, it's not possible. And the error, MSR, for this is like 0.05, like that. One is 0 and another one is 5%. I can say like the square difference between the actual and predicted value. But when we talk about this MSR, when we talk about this accuracy, we say that the purchases and sales on this respective NSE indices only it is reduced. So the average error in predicting all these things is very much important, which help the entire society over here. What is the result and conclusion I would like to place it over here is what type of significant relationship which has got over here for uncertain action or robustness where we are not able to predict it, it's like a tsunami. So if that is the case, the impact on the behavior of the stock market. Every stock market have a changes and fluctuations with respect to different types of sectors. It can be bank, it can be manufacturing, production, IT, healthcare, etc. So we can bring out some different beautiful policies and the researchers may understand the dynamics of the Indian stock market. What is the future scope? We can have it over here is analyzing these factors, we can give the government influences behaviors and what is the mitigators over here towards the market volatility and how this Indian stock market attract long-term foreign investments. So we can use convolutional neural network for the complex relationships. These are the references. Thank you.
Thank you so much, ma'am, for the wonderful presentation. Participants, if you have any queries, you can kindly unmute and ask, or else you can post it in the chat box too.
Yes, I'm ready to answer to your queries. This is a learning point from my side also. If you ask any question, I can develop some algorithm from that.
Ma'am, I have a basic question, ma'am.
Yes, ma'am, please.
Actually, in the data pre-processing, I don't understand the data cleaning process. How do we do, ma'am? Is
We
there
got,
any software?
yes, you got n number of techniques to clean the data, ma'am.
Okay,
N number
ma'am.
of techniques. And we may have a doubt which technique has to be used. How do we know that I have to? We always see that the maximum which technique, the pre-processing technique. See, computer science people say pre-processing, we say cleaning, normalizing. It's our term, mathematical term, but all are same. So this cleaning the data is very important. The reason is like when we apply some technique to clean the data, there are chances some only 30 to 40% will be cleaned. Without
Okay.
knowing that accuracy of the cleaning or pre-processing, we try to use the technique, but somehow we'll get the results. But
Yes, ma'am.
that will affect our decision.
Yes, ma'am.
So many techniques are there. We have to analyze which gives the highest percentage or optimal percentage of accuracy. That technique we have to take.
Okay, ma'am. Thank you, ma'am.
No problem.
Yes, ma'am. And one more doubt,
Ma'am,
ma'am. Yes, sir. Jackson, sir,
hello,
proceed.
ma'am. Shall I ask one question, ma'am?
Please, sir.
Ma'am, after completing one algorithm, how we check the accuracy of that algorithm?
Actually, sir, if you have a confusion matrix, there are some statistical measures like accuracy, sensitivity, specific, all these things. We try to basically classify it in terms of true negative, true positive, false positive, like that. When we use that, you will get the accuracy based on the formula. That's possible always. The highest accuracy of running that algorithm, we are trying to take it in terms of percentage.
Okay. Okay, ma'am. Thank you, ma'am.
Thank you, sir.
Ma'am, my question is, we have applied k-means algorithm in a particular data set, ma'am. So we have applied different algorithms. After that, we plotted a graph scatter plot. So while writing the inference, I have a doubt whether I am writing the correct interpretation, correct inference, because the scatter plot is somehow it is scattered in a different way. I am not able to get the correct inference, ma'am.
Okay, that's nice. Nice question, ma'am. Actually, when we talk about this k-means clustering, we have some problems in k-means. That means we call it as a disadvantages. The meaning is like it is the sensitivity. Mathematically speaking, we have some centroids. Okay, ma'am? And the centroids, this k-means works to be the best when the initial points are carefully chosen. We try to say that the initial value x naught, y naught, like that. And another thing is sometimes it converges to the sub-optimal problem and if the initial centroids are not properly chosen. The second point is how many clusters we want to have. Sometimes we try to say that I want to classify this data group of children in my class only 2 clusters. then immediately my mind will come to a conclusion. Split it as girls and boys. That's it. Close it. I'm not bothered about. The third idea of transgender does not enter. So
Yes,
it's going to be another future which has to be extracted. That doesn't happen. So in order to have this, like, there are some restrictions on this K that we have to check it with our other algorithms in such a way that that algorithm may give more beautiful clusters with less number value as K also. That's also possible.
okay, ma'am. And can we use other, except Python programming, can we use
Yes, ma'am,
other?
MATLAB. I have
Okay,
used MATLAB, ma'am.
okay, ma'am. Okay,
I told Python because the
okay.
reason is open source.
Yes, ma'am.
Many institutions may not have anything like it's difficult to purchase because it's a high end, costly.
Yes, ma'am.
So Python you can use it. I have used MATLAB as well as Python.
Okay, ma'am. Thank you, ma'am. And one question from the participant, ma'am.
Yes, ma'am. Is it in
Uh,
the chat, ma'am? Is it in the chat?
no, ma'am.
Okay.
Personally,
Personal chat. No
he sent
problem.
to me.
Yeah, please.
How
Please.
machine learning is being applied in interdisciplinary field?
Okay. Interdisciplinary, I do not know which field that madam or sir is from,
Yes,
but
ma'am.
I can just post you something like a small, at layman point of view, a small application. Recently, I had an opportunity to meet one doctor at Apollo Hospital.
Okay, ma'am.
So very simple example. I was just asking him, and because I always wonder from my childhood, like when the X-ray is taken, they keep it on that with the light. They say, yes, yes, you have cardiac arrest. You have single block. You have multiple block. Am I correct, madam?
Yes, ma'am.
So
Absolutely.
I always have a doubt, like, is it like Joshim or anything like that, or does he have any supreme power to analyze me? Because he doesn't know Vijay, who is Vijay. So how he analyzes this? Then this doctor was, I was just asking this question to doctor. Doctor, I was thinking like it is only the medical background of some transformation technique they are using or something like that. Doctor was telling it's very clear, like the domain is divided into a 4 quadrants, like where when you visualize the nature of your signals inside that using ECG or EEG, it goes up and down like that.
Yes, ma'am.
And where you could see like so much of fluctuations over there, they plot that particular region, and in max we say neighborhood regions, they
Yes.
cover that place and they try to say like that. So that
Oh,
is one application how it goes on.
okay, ma'am. Actually, the person who asked that question is under mathematical background, but under the interdisciplinary guide.
Right.
That is from
Which is
commerce person, commerce.
commerce. Commerce, I think my presentation would have been the
The
optimal
best, yes,
presentation,
ma'am.
like,
Yes,
because I took it as
very.
a, because I always tell to my friends and my family also, don't do this purchase, sales, and stock market, because we could read so much history and geography from the daily social media, lost 2 crores, 3 crores, like that.
Yes, ma'am.
But we are giving some alarm or a policy to the government maker using mathematical statistical models. That's the one thing, ma'am.
Thank you so much,
No
ma'am,
problem.
for the clarifications.
Thank you. Thank you.
Participants, if you have any other queries, please feel free to ask. The forum is open. I hope it's clear, ma'am. There's
Okay.
no questions.
Ma'am, at the outset, I would like to thank Almighty for helping me without any power shutdown.
Yes, ma'am.
And I would like to thank the higher authorities of this esteemed institution, Professor Deva Manoharan sir, head of the department, organizers, Dr. Martina Jensi madam, and wonderful audience for listening to my lecture. Thank you so much. Hello, ma'am.
Yes, ma'am. Yes, ma'am. Yes, ma'am. Thank you, ma'am. Pandiselvi, ma'am.
Thank you. Yes, ma'am. Finally, I invite Dr. S. Jackson, Assistant Professor of Mathematics, to propose a vote of thanks.
Am I audible, ma'am?
Yes, sir. Yes, sir.
So, good evening, everyone gathered here. It's my privilege to extend a vote of thanks on behalf of the organizing committee of this faculty development program on exploring new horizons in mathematical research. Firstly, I would like to express our profound gratitude to our Honorable Secretary Sir, Shri A.P.C.V. Chokalingam, for permitting us to conduct this faculty development program. I would like to also thank our beloved Principal Sir, Dr. C. Veerabahu, for his constant support and encouragement in organizing this event. A special thanks to today's resource person, uh, Professor Dr. Vijayalakhsmi ma'am, Professor Applied Mathematics and Statistics Department, Central University of Thiruvarur, for her invaluable contribution. Your session was not only informative but also provided practical insights into the latest trends and methodologies in mathematical research, ma'am. We are truly grateful for the knowledge you have shared.
Thank you, sir.
I extend my gratitude to the HOD sir, Dr. C. Devamanoharan, our colleagues and committee members whose hard work behind the scenes made this program a success. Without their dedication and meticulous planning, this event would not have been possible. I must also thank our technical team who ensured that everything ran smoothly. Their efforts are much appreciated. The technical team led by Professor Gomudi Nayagam, head our Department of Computer Science, unaided. Thank you, sir. Thanks for your wonderful support. I must also thank all the participants for their active involvement throughout the session, the 6 days. Your enthusiasm and eagerness to learn have made this program a lively and productive experience. Once again, I thank everyone for making this faculty development program a great success. I wish you all the very best in your future academic endeavors. Thank you and have a great day.
Thank you all. I would like to extend my sincere thanks to all the Department of Mathematics colleagues. Thank you all.
Thank you, ma'am.
Thank you so
And
much.
Thank you, ma'am.
my dear participants, one announcement that you will receive your certificate within a week, span of weeks. After we are going to check all your attendance, and after consolidating the attendance only, we will give the certificate and we will post it before within a week. Thank you.
Thank you, Professor Jackson, sir.
Thank you,
Madam,
ma'am. Thank you.
Madam, can I leave, Madam?
Yes, ma'am. Sure, ma'am. Thank you, ma'am.